Hi everybody, welcome. Hope your day is going well. This is going to be our video on properties of exponents. And for today, our biggest goal is to learn how to apply exponents and their meaning. And I think that's going to be really important to understand. We kind of talked about that already. So I want you to think about, what does an exponent actually mean and why do we use them? So this is the exploration we were trying to do in class, but it didn't really work very well on online. So let's try it here. We're going to go through a few for a little bit, and then we'll have some practice problems to go along with it. So here's our essential question. Let me back up for a second. This is in your student journal on page 168. So we're going to use your Algebra 1 student journal right there on page 168. This is where we can find that. So if you could flip to that, that would be great. We're going to go through here. So our essential question is, how can you write general rules involving properties of exponents? Okay, so we need to know what an exponent means. So let's start with that. So what happens when you multiply two powers with the same base? Write out the product of two powers as a single power, and then write the general rule. Okay, blah, blah, blah. Right, so what does this stuff actually mean? So when I look at 2 squared, what does 2 squared mean? Or 2 to the second power? That means 2 times 2. That's what the first set of parentheses means. The second set of parentheses, 2 to the third power, means 2 times 2 times 2. So this is multiplying those 2's 3 times. So altogether, whenever we have parentheses next to each other like that, that always means multiplication. So this is 2 times 2 times 2 times 2 times 2. So altogether, this is 2 multiplied how many times? 5 times. So this is 2 to the 5th power, which we could get would be 32 if we work it out, right? So 2 squared and 2 cubed make 2 to the 5th power. Let's go over here. 4 to the 1st. What does that mean? That means 4 one time, right? So it's 4 times, and then 4 to the 5th means 4 times 4 times 4 times 4 times 4. So altogether, we have how many 4s there? 2, 3, 4, 5, 6 4s. That is the same as multiplying 4 6 times. So this is equivalent to 4 to the 6th power. We come over here, 5 to the 3rd is 5 times 5 times 5. 5 to the 5th is 5 times 5 times 5 times 5 times 5. So 5 5s. Altogether, we have how many 5s multiplying? There's 3 there, 5 there. A total of 1, 2, 3, 4, 5, 6, 7, 8. So this is 5 to the 8th power. And then finally, this is x times x, which is x squared. And then there's 6 x's. So in total, we have 2 here, 3, 4, 5, 6, 7, 8 again. So this is x to the 8th power. Is x to the 8th power. So what is the general rule for this? So what is actually going on here? Well, some of you may have noticed that in total, we had 5 2's here, we had 8 5's here, but there were 2 2's and 3 2's, so there was a total of 5 2's. So one rule we could write is that when you take some number like a to a certain power, let's say the letter m, that just stands for the exponent, and you multiply it by itself, but a different number of times, the result is you can add the exponents. You can add the exponents. So this one right here, like if we did another example, 7 squared times 7 to the 9th power, that is equal to 7. There's 2 here, there's 9 there. So there's a total of 7 is 2 plus 9, 7 to the 11th power. That is one rule we can write for exponents. What about here? What happens when you divide 2 powers? Well, let's write out what these mean, right? So 4 times 4 times 4, that is in the numerator or top of the fraction, and then 4 times 4 is on the bottom. So what do we know about some fractions when you divide like this? Well, one thing we should know is that if I do this off to the side, if I take 4 divided by itself, do you know what you get? If you don't, you could test on your calculator if you want. But if you do this, 4 divided by itself is 1. So any place where I can divide a 4, I'm going to make sure I get a 1. So 4 divided by 4, that is equal to 1. 4 divided by 4 is equal to 1. So this whole thing is equal to 1 times 1 times 4. Well, what is 1 times 1 times 4? 1 times 1 is 1. 1 times anything is 4, or is itself. So this all works out to 4. And how many are there? There are 4 to the first power. There's only 1 4 left. What about over here? Let's check that out. So there's 5 2's on the top in the numerator, and there are 2 2's on the bottom. So if we apply that same sort of idea, that if I divide this 2 by that 2, I get 1. If I divide this 2 by that 2, I get a 1. But there are no more 2's to divide, so we're done, right? So we are left with just 1 times 1 times 2 times 2 times 2. 1 times 1 is just 1. It doesn't really do anything. So this is 2 times 2 times 2, which is 2 to the third power, which is 8. So this whole thing simplifies to 2 to the third power. Then what about this one? There's 6 x's on the top, 3 x's on the bottom. So this x divided by that x is a 1. This x divided by this x is a 1. This one and this one, that's a 1. So you're left with 1 times 1 times 1 times x times x times x. Well, altogether, you are left with the 1's just are 1. They don't really mean too much or matter too much because 1 times anything is itself. But these x's are x to the third power. So this whole thing works out to x to the third power. And then finally, over here, what happens when we get this? 3 times 3 times 3. That's the top. There's 4 3's. The bottom is 3 times 3 times 3 times 3. There's 4 of them. So now let's just use our idea of dividing, right? So this 3 divided by that 3 is a 1. This divided by that is a 1. That's a 1. That's a 1. Oh, look at that. All the 3's are able to divide out. So what are we left with? We're left with 1 times 1 times 1 times 1. So what is that? That is equal to 1. So somehow this whole thing works out to be just 1 because we divide the whole top divides the whole bottom. So what can we learn from this? Well, you may have noticed when you're going through here, it's like, well, what can we do with our exponents? Well, according to this, if you look at the exponents, this was 3, this was 2, the result was 1. This was 5, this was 2, the resulting exponent was 3. This was 6, that was 3, that was 3. So what we can do is when we divide, we can actually subtract the powers for the same sort of base. So if it's, subtract the powers for 2, subtract the exponents for 4. And that's one rule we can write for our division of powers like that. So let's say, so here's our rule. I'm going to put it down. I'm going to put it over here. Put it over here. So what's our rule? So if I take a number to this power divided by itself to a different power, the answer will be subtract the top minus the bottom. So for example, if I take 7 to the 9th power and I divide it by 7 to the 4th power, this is going to be equal to, there's 9 7's on the top, 4 on the bottom. I could wipe out 4 on the bottom, and that would leave me with 7, 9 minus 4 would be 7 to the 5th power remaining in our expression. In my opinion, personally, I think writing out the powers is the exponents and the powers are extremely helpful. I think it's easier to see what you are left with when you do this and what happens when you divide, or what happens like up here when you combine. I think writing these out. So I'm gonna always recommend and ask that you write out the exponents. You always write them out. You write out the multiplication, okay? I think it's a good thing to do. I think it helps you until you get really comfortable with the rules, but that is why the rules work. So this first video was all about the rules where you can add the exponents. And this one over here, the other rule, is where you can subtract the exponents. Okay, when you divide, you can subtract, and when you multiply them, you can add. But I think if you write out the meanings, it helps out understand that a little bit better. Okay, we got another video coming to take care of that, but for today, we were going to take care of the adding and subtracting of powers.